Yeda obade ase sa ne da osoro ene asase so ase. Som obade na abode ensom bibia ewo edisuamu agibo technology eni. Today we are coming to learn about photocell, a system that it will step it down off our outside light during the day and I'm using the two sides, outside light during the night, as well as our street lights are concerned. Before, let's consider the power supply circuit that it will supply the light controlling system. So please look on the board. Full wave bridge rectify. Full wave bridge rectify. Here we are going to use 6 volts center type transformer. (220 volts AC to 250 volts AC 50x. This is 6 volts AC, 6 volts AC, 0 volts. So this is a step down transformer. It's receiving 220 to 250 volts AC and step it down to 6 volts AC. But our light controlling system, it uses DC, so we will introduce rectified diode. We have so many types of diode, but here we will use rectified diode. So full wave bridge rectify uses 4 diodes. Now this is a diode. Here is cathode and here is anode. So here is positive, negative. Here, negative, positive. You see, the same. Apply. Okay, this is the primary side of the transformer, and here is the secondary side of the transformer. You see, I'm using the 2 sides because it's the center type XMA. This is the XMA, which is 300 milliamps. 300 milliamps XMA. Then it is center type, right? So you can use 12 volts, but I'm using 6 volts center type transformer. So here, when you check the waveform here, now you see the AC is alternative current. It's alternative current. The alternative current is to and fro. It's to and fro. It's like this. The alternative current is like this. It's to and fro like this, right? Okay, but now the DC, we want the DC, so we have introduced this rectified diode, and it's a semiconductor diode. So it has been convert the AC into DC. So now when we check the waveform here, now it has become like this. It has become like this, right? Okay, but it is a varying DC. It is a varying DC. This one, like if you have a sound system and you connect to it, you will hear humming. It means that it needs a filter, a capacitor, which will make it steady, which will make the waveform straight away, make a waveform like this, very straight, very smoothly. So we will introduce a capacitor. This is a capacitor. Here is a positive and then the negative. Then it's connected to the anode here. The capacitor we are using is 16 volts by 10,000 microfarad. 10,000 microfarad is a very high capacitance. We want the filter with filter. So in this, when you connect to your sound system, you enjoy the sound very well. Okay, so this is the power supply that we are going to use for our light controlling system. This is the step down, and it have been stepped down to 6 volts AC, and I'm using the 2 sides, so it's giving me 12 volts. So here it will give me 12 volts DC here, 12 volts DC. It will give me 12 volts DC. So now we can connect to our light controlling system. Light controlling system. Light controlling system. This is light controlling system circuits. Light controlling system circuits. Now, this is the light controlling system circuit. Let's connect our bulb. This is the circuit diagram for light controlling system circuit diagram. And here are the components used. 12 volts relay, rectifier diode, C1815 DR2, 570 kilo ohms resistor, light dependent resistor LDR, the load, the supply 220 volts AC, the bulb 220 volts AC bulb. In this circuit, the 5 kilo ohms resistor is on. It's on in this circuit, meaning it causes the load to be on during the night. The light dependent resistor, the LDR, is off in this circuit. Is the one which causes the load or the bulb to off during the day. So let's look at how the resistor 570 kilo ohm causes on to the load or the bulb. It's receiving the positive voltage, the VCC, and reduce, as we all know, the resistor is reducing the flow of electric current, so it's reduce the flow of the positive to the base here, and it will open the base and allow the Q2 to bring the positive to the emitter here and send it to the base here. Send it to the base here, you see. So if the Q1 receives the positive, it will open the base and allow the negative and release the negative to the collector, and then it connects to the relay pin 86. Meanwhile, 85 is connected to the positive, so the relay will come on. So it will generate a magnetic electromagnet, and it will attract the pin 30 to 87 and cause the load to be on. Let's see how the LDR cause the load to goes off. You see, at the daytime, the light strike on this LDR, it will start conducting, because LDR, when the light strike on it start conducting. So it will conduct the negative to the base here, to the Q2, and repel this positive from 570 kilo ohms. So as it repels the positive, it will close Q2 and stop it bringing positive to the emitter to Q1 base. If the Q1 loses its positive, it will close So the emitter will stop bringing the negative to the collector. So it will cause the relay pin 86 to goes off. So when pin 86 goes off, then the electromagnet will stop operation and let the 30 will come and rest at pin 87. That causes the load off. Thank you for watching. This is Hajibo Technology. Everything is in education. If there's anything, please draw my attention. God bless you all. God bless everybody. See you in the next video.